All right, hi everyone. I'm Kasey Uhlenhuth. I'm program manager on the .NET and Visual Studio team at Microsoft. Hopefully some of you all came out last night at the .NET user group, maybe some of you, and saw me walk through like what was new in Visual Studio 2017. And part of that, I showed what Roslyn analyzers were. So in today's session, we're going to go through how you can build a Roslyn analyzer, and then like what the heck that even is, etc. All right, so here's the brief agenda for those of you who like to know what we're going to do up front. So we'll talk about what analyzers are, what this mysterious Roslyn thing is. We'll go through the different APIs that exist, what tools you need to build an analyzer, and then we'll build an analyzer and a fixer. And then you can join our awesome third-party ecosystem if you want. All right, but why should anyone care? Like, why are you here? Well, one of the top feedbacks we get in Visual Studio, just in general for productivity, is people say, I wish I had a refactoring that did X, Y, Z. Or, can't you make, remove all my logline calls for me? Or, can you convert these multi-line strings that I have to a single line? And so people have all these, or you might have a super weird naming convention on your team that we don't support. And you want to throw an error if people violate it and don't use that naming convention. And so these are top requests that we get, but as the compiler team, it doesn't make sense for us to make these compiler errors and force them on the entire world. And so that's why Roslyn analyzers exist, so that you can write your own to enforce whatever you want on yourself, on your team, for your library, etc. And so here's just an example of what a Roslyn analyzer looks like. It's that squiggle that you see letting you know that there's a violation. So that's part of the diagnostic. And then you can use the light bulb to provide a fixer that will then fix whatever your error was. And so that's the main point, is that if there is something that you want to use to make your life easier, so there's some repetitive task you're doing over and over again with refactoring or code generation, etc., this is what you can use an analyzer for. And then if you are a library author, this is probably my favorite example. So the XUnit team, you may have noticed one day your XUnit NuGet package upgraded and you had a bajillion errors and you're like, what just happened? And that was because they added a Roslyn analyzer NuGet package to their NuGet, so that you get this sort of enforcement to help you learn how to properly use XUnit. So here, people were using the attributes incorrectly for different types, and so here they offer the fixes to help you make it actually compile and work based on how they do their library. And so if you're a library author, you can use these to help enforce the right way of using your APIs. So that's another reason why you might want to look into writing these. So I'm not going to truly demo something right now, but I'm going to show you how approachable these are, hopefully. So this is what one looks like on GitHub. All right, so this is just an analyzer that squiggles if a log line exists. So it was that initial screenshot. You can see all my code fits on just this little screen right here. All this up here is boilerplate. And the only real code I wrote was right down here. And so that's 7 lines of code, essentially. So that's how approachable these things are to writing. It's not once you wrap your head around the concepts, putting it together is not very many lines of code at all. And the fixer is 10 lines of code. So that's just a brief look at where we're headed at the end of this talk to let you know, it's going to be okay. We're going to get through this. Compilers can be cool. All right. So back to the PowerPoint. All right. So what is an analyzer? An analyzer has 2 parts. The first is mandatory and not optional. So that's the diagnostic. Diagnostic is just the squiggle that we put in the editor. So if you have that logline call, you say, oh, where do I want to draw the squiggle so that there's a known violation? And then if you have that, it's going to break the build if you have an error. So diagnostics run anywhere that your code runs. So it can run your CI, whatever. And then the optional part that an analyzer can have is a fixer. A fixer is tied to UI. So it must be in Visual Studio, or soon, hopefully, you can write one analyzer that will work with VS Code and Visual Studio for Mac. When you do that, it's tied to that UI. So again, it won't run. You can't have these fixers run in your CI. But you can use them inside Visual Studio to then fix however you want. So that's the two main parts of an analyzer, and we're going to build both of them. So what is this thing Roslyn that I keep talking about? Roslyn is the code name for our project. The true name is the .NET compiler platform, but like that doesn't mean anything anyway, so might as well just call it Roslyn. And so Roslyn is where we completely re-architected the C# and Visual Basic compiler from native code into managed code. I think it took 7 years to do that, so a long time. And you might be like, why the heck would you do that? Great question. There's two main reasons we did it. The first was so that we could write new features faster. By features, I mean new language features. So if you went to Mads and John's session yesterday or their session today, you probably saw that like we're already talking about C# 8, and it's been I don't even know anymore. It's been 4 years since I joined the team, and that was when C# 6 came out, and now there's been 7, 7.1, 7.2, 7.3, and now we're like talking about 8 already and have prototypes, which just shows how fast language development can happen now. We can do these point releases, we can get you prototypes, things that we could never have done on the old compiler that we had. Also, we can write new IDE features faster. So any refactoring that you see in Visual Studio, you may have noticed like every update or point release of Visual Studio, we also have more fixes and more refactorings. And that's because it becomes almost trivial for us to write them. Not really, but like compared to how it used to be. And then the second reason that we did it, why did we re-architect all of this? Was so that we could create an open source API surface over the entire compiler so that anyone could write a code-focused tool or technology. And so this is where analyzers come from. So now, rather than the compiler being this sort of black box where you don't know what's happening in there and all of a sudden it spits out IL and it's all good, you can now, with it being opened up, access all of these different APIs that we've made available to build what you need. And so here, I've just abstracted them out into 4 main APIs. There's a lot more, but here's the gist, and then here's what you can sort of build with them. So the syntax tree API, it's high fidelity representation of your source code. That's how you write formatting tools, because white space matters in formatting. The symbol APIs, where you want more semantic-y related things, like if you want to navigate to types or members. The binding API lets you do things like extract method, and then the emit API, which if you truly want to do some crazy stuff, you can use that. That's what edit and continue, for example, is built on today. So that's like an overview of what APIs we have. Now let's dig into the first 2, because those are the 2 that we'll be using today. So the syntax tree API. This is my rough sketch of a syntax tree to make it as less scary as possible. So a syntax tree has nodes. Nodes represent syntactic constructs like declarations, expressions, etc. And then you have tokens, which are these green things. And tokens are like keywords, literals, identifiers, what have you. And then we have trivia, which is what makes our syntax tree perhaps different than other ones you've seen, is that all this white space and like preprocessor directives and comments are all captured in our syntax tree as well. So that's important if you're writing one of these tools that does a refactoring or moves code around. You want to keep comments or duplicate comments. You need that information. And so all of that is in our syntax tree. So it's a high fidelity representation of your source code. The 2 then properties of the syntax tree are that, again, it's the complete representation of your code and that they're immutable. And they're immutable, that's important because then, if multiple users are working on that syntax tree, you're not having like mixed up state. So it's like, I work on my syntax tree, I do something, see if it can be applied. If it can't, throw it out, do it again, kind of thing, rather than us all mutating this same tree and then getting in some crazy state with your code. The other advantage of it being immutable is for those of you who are in Visual Studio 2015 or 2017, you probably have seen this little diff view when you access the light bulb, where we do a live diff. And that's because we have 2 trees, because they're immutable, and we can diff them and show you what the code change is going to do. And so just another, like from the tooling perspective, what we're able to do with these syntax trees being immutable. So, pretty cool. The other API that we're going to talk about is the Semantic Model. The Semantic Model lets you access semantic information. So, like, is this a field or is this a property? What is the name of this method? What is the type of this parameter? So if you want the answers to those questions, you need to ask the Semantic Model. And that's where that comes in. The Semantic Model also has knowledge of the compilation. So if you need something from metadata, et cetera, you can get that from your Semantic Model. All right, so how do these two APIs interact with each other? So you have your syntax tree, your Semantic Model. How do they work together? Well, from a node in your syntax tree, you then ask questions to your Semantic Model, like, what type am I? And the Semantic Model will then return that to you. And so that's how you can go through. You're like, oh, I'm at this node. I need more information. I'm going to get my Semantic Model, ask it some questions, get the answer, and continue on my merry way. Which is all fine and dandy, except what if you don't need that sort of nitty-gritty information from your syntax tree? Like, you're writing something that only has to do with semantics. You don't care about white space. You don't care about comments. You're never going to touch them. What do? Well, we have this new tree called IOperation, which is what we're going to use later today. And IOperation is a higher level of abstraction over this. So, for example, if you have multiple shapes of the same thing in the language, it can abstract over both those shapes. And it's so high level that it even abstracts over languages. So you can write one analyzer using the IOperation API that works for Visual Basic and C#. So if that's important to you and your team, that's what you can do here. But it also works across shapes within the same language, which we'll see an example of that in a second. How IOperation works in this entire model that we have set up is you get your operation from your Semantic Model, and then from your IOperation tree, you then, if you need more nitty-gritty information, you can go back and ask questions to your syntax tree to get information like, what is my span or my location in this document? And then here are the reasons why you would use the different APIs. So if you care about formatting or syntax patterns, you would use your syntax tree API. If you only care about semantic patterns, or if you need that cross-language support, then IOperation might be the thing for you. All right, so that was a lot. So let's take a sec, recap slide. So again, there's a syntax tree. That's the high-fidelity representation of your source code. Includes white space, all sorts of other trivia. You have the Semantic Model, where you learn semantic information. Then you have IOperation, which is the newest evolution of the Roslyn APIs that abstracts over syntactic shapes. And it's probably more similar to what you all may have in school learned as a syntax tree. And then the last API that we're going to use today when we write our fixer is the syntax generator, which allows you to language agnostically create syntax. So we'll get into that, but the gist of a fixer is that you're going to go and create a new subtree where you're going to have the syntax of the fix, and then you're going to swap it into that original syntax tree out with the node that you want to change, and then return that new syntax tree. And that's essentially how a fix is going to work. All right, so that was a lot, and that's the theory, yada yada. So let's build something. Does that sound good? All right. So you have to have tools. We made this easy. We have templates for you. There's our documentation, which is just the source code. And then install instructions now. So this is how you get started. The tools that you're really going to want are the syntax visualizer, which comes with the SDK, and then these analyzer and fixer templates that we provide for you. And then the link to our documentation is just source.roslyn.io, which lets you symbolically navigate our source code from the web. When you're in Visual Studio or installing it, if you want to get the SDK right away, you just go to the workload that's the Visual Studio extension development one, and then make sure that highlighted spot is checked. And that's how you can get the templates to write these. Cool. All right. So what are we going to build today? We're going to build an analyzer that finds every spot where you've newed up a zero-length array, and we're going to suggest that you use array.empty instead. So it's just like reduce the number of allocations that you make. That's all we're going to do. So we're going to be looking for any place that you knew up empty or a zero length array, and then suggest that you do this instead. Now, if we did this with the syntax tree API, we would have to look and realize that there's two different ways to new up a zero length array, right? There's the way on the left, and there's the way on the right. And when you're dealing with syntax, like these look completely different. So their syntax trees are totally different. This is what the first one looks like. So you could see if you wanted to see if it was a zero length array, you would go back, follow it down and then find that 0 and say, oh, it's of length 0. But if you go to the other one, it's a bit more monstrous looking, and then you come down and there's like this omitted token thing that you would have to look for inside to be able to even tell that that was of length 0. And so traditionally, before ioperation, you would have to go through and parse these two different types of syntax and account for both of those in your analyzer to see if you found a zero length array. But this is where ioperation comes in, and the ioperation tree abstracts over these two different shapes, and there's just a concept of an array creation. And from that, you can get dimensions and things like that. So I can show you, going to our handy-dandy documentation, the source code. You'll see here on source.roslyn.io, you can just search in here. So I'm just searching for the ioperation. And here, if I zoom in, you can see here's what ioperation looks like. It has parents, it has kinds, it has syntax, types, etc. And so we'll just be coming back to this frequently to figure out why things are going on. But this is the basis for how we're going to move forward for the rest of the talk. All right, so now we're in Visual Studio. This is what you're going to want to do. So when you do file new after you've installed the SDK, you're going to see this template. So you can write an analyzer with a code fix. There's just a template for it. There's also a refactoring, but we'll get into that later. And so, here's the template that you want. I already have it open. I deleted a lot of the boilerplate. So the initial one comes with an example where it will find, I think, all your class names and offer to make them all uppercase. So it's just like a silly little example to show you a basic analyzer. And so we're going to just go through and do this other one instead. So I deleted all the comments that are in here, and this is essentially what you have. If all fits, I think, on the screen. All right. So half of this is boilerplate, or maybe more. All of this, beautiful. So what is it doing? This first chunk is just giving you what strings do you want to appear to the user. So what's the title? What is the message format, the description, etc. And they're all managed in this resources file. So I could come in here, I don't know, say NDC Oslo. Yay. Just so that you know that it's real as well. Okay. So you can add whatever you want in here, what messages you want to appear when they hover, when they do control dot and get the light bulb, etc. So I have that, or what shows in the error list as well. So that's all that was in here. The other thing you'll notice, I guess live unit testing died. Oh, well, okay. You can set a category for this as well. And then all these are bundled up into something called a diagnostic descriptor. So this is just something that describes your diagnostic. And so in here, you can see that it comes with the ID, then it takes that title, message, category. You can choose what, zoom. You can see, Jesus, okay, here we go. Nope. All right, I don't even know why I'm using a mouse anyways. Okay, here we go. You can put the default severity of your analyzer in here. So if you want it to be a suggestion, if you want it to be off by default, whatever, you can change it in here. So you can come in here and see you can make it a warning, error, info, or hidden, which means not shown at all. So we're just going to keep it as a warning because I wrote unit tests. So we're just going to keep it that way so I don't have to change anything. And that's just all bundled up into this diagnostic descriptor. And then this is the main meat. This is the meat of it, we're just going to this initialize function, and then we're going to register a callback. So when our code analysis goes through this document, we're going to say, hey, when you see like array that's been created, I want you to see if it's of length 0, and if it is, I want to report a diagnostic and put in a squiggle. That's what we're doing here. So we're just going to come in here. And if I come into my context, so the only thing we have available here is context. When I do this, let's do some zoom in. If I type register, you can see that you can register all sorts of different actions, or like on different actions. So like typically people do like syntax. So when you see a syntax node, you're looking for this, or at the start of a compilation, or when you see a code block, etc. Because we're using ioperation, we're going to say when you see an operation. So that's what we're going to start with. And then it's asking for our callback. So we're just going to call our callback like analyze operation. Why not? And then it's looking for a kind. So what is our operation kind? So when we see what, are we going to trigger this? So if we go back to our handy dandy documentation, we can see that there's the operation kind here. We're going to click on this and see what kinds there are. And we're just going to hope that there's something called array something. And sure enough, I missed it. I was on it in the beginning. Yep, here we go. You can see that there's something called array creation, and it has this information, so it's tied to this. And so if we click on the array creation operation, we can see, looking at it, it has this beautiful thing, dimension sizes, where we can get the dimension of our array. So we don't have to check those two different syntaxes. There's just this one array creation thing, and it has dimension sizes. It doesn't matter which type of newed up zero length array syntax you used. So that's what we're going to use. So we're going to come in here, have our operation kind. We're looking for that array creation. I'm going to use control dot to generate this method. That's why there's that squiggle, because it hasn't been written yet. If I use control dot, it'll generate it for me. I said that I want to use expression body members, so I'm going to come here and switch it to a block body so you all can read it. And then I'm going to rename this to context, so that matches my operation analysis context better. All right. So now that we're in here, this is our callback. So what the heck are we going to do in this? The gist of what we're going to do is what I said earlier. We're just going to say, hey, we have this array creation expression. Is it of 0 length? And are the dimension sizes 0? And if they are, report a diagnostic. So we're going to come in here. We're going to get our array creation expression. So from our context, we can get the operation. We're going to cast it, though, as that array creation operation. So now we have our array creation. Then we're just going to say, hey, if this thing has a dimension, so if it has that, if it has a dimension, then we're going to come in here, array creation, dimension sizes, grab it, because we know it's a length 1. And so if you're wondering what these stars are, by the way, we're doing this foray into how AI-assisted technology can make developers more productive. And so this is like we machine learned on some GitHub repos and figured out based on people's context what members of different types and stuff are they using, and then we're putting them at the top. And so I guess the version of the model that we updated yesterday has Roslyn in it. And so it's trained on the Roslyn code base. And so it's suggesting things that my team has used here. So that's why you're seeing all these starred things, which they are going to come in handy. So constant value and then has value is what I wanted. You can see like suggested it here, if you can see that. So pretty handy. I have to scroll less now, so it's helping me learn this new API I'm unfamiliar with. Once I'm in here, I can grab my dimensions. So come in here, dimension sizes. Yep. Oh, see, it like wrote that line for me. Beautiful. So it turns out, though, if I use one of our new refactorings where you can toggle between explicit type and the implicit type, dimension is an object. So in order to see if it's 0, I have to do this thing that we hate. If it's an int, and then cast it as an int, and and then check if it's 0. However, how many of you are using C#7? Yeah. All right. So yay, I can, because I'm checking here, both the shape and the value of this expression, I can just use pattern matching. So just get rid of all that. There we go. Nice and readable. So that's pattern matching, by the way. And so now that I know it's of size 0, I just create my diagnostic. So create a diagnostic. So I created it. I give it that descriptor. So it wants like, oh, what are all the like data and details about this that we need to present? So that's that rule that we put up above, up here. This rule where we said what our default severity was, what the ID was, the title from that resources file. So we put that in there, and then it needs a location. So location is from the syntax tree, which we don't have right now. We have our operation. So from our operation, we need to grab our syntax, and then from there, get location is something that we can call. And so what's happening here is that we need that location because we need to know where exactly in the document we need to draw this squiggle. And so that's why we have that. So we're saying, hey, squiggle it under this array creation expression that we have. So that's what that's doing. And then you have to remember to report the diagnostic, which is the number one thing I forget to do every single time. Because if you don't report it anywhere, then it just is sent into the abyss and doesn't do anything. All right, so we've written it. If my live unit testing was working, you would see all my tests are passing, maybe, hopefully. We'll find out in a second. So you can either write unit tests, so I can show you what, okay, except that I have my fixer in here. Oh, maybe not. Come on. No, you shouldn't have to save. But, oh, here we go. Let's just go to, I'll show you what a unit test looks like, because they're kind of crazy. We're going to probably fix it soon. So if I come in here, you can see that you're like, oh, you give it string of your program. So like here I have a 0 length array and a string. And then you're saying, oh, like what is the diagnostic result you expected? So you have to give it like all that information from that resources file. You have to say where the squiggle is going to appear, and then you verify that it happened. Oh, you're right. That's what it was. So, you know, screw testing. We're just gonna run it and see what happens. So if you hit F5, don't tell anyone that I hate testing. So if you click F5, what we're gonna do is we're gonna spin up a new instance of Visual Studio. And we're gonna package this analyzer as an extension with the file extension v6. Install it into this Visual Studio, and then you should just be able to open up any project, write a 0 length array, and then have it work. So here I'm opening a project where I already have some written. And in here, once it opens, you'll see. But because it's taking a while, I'm going to subject you to my cow jokes. What do you call a cow with no legs? Not steak. Anyone else got anything? Burger? Ground beef. Terrible, I know. So if I come to tools, extensions, and updates, you'll see that my analyzer ORama is installed as an extension here. And so it's running. And then sure enough, my 0 length arrays are squiggled. And if you can see there, I hover over and it has my message for me. But it did not squiggle the one that's not 0 length. Cool. So that's how you can test how it works. Just hit F5. We spin up a new instance of Visual Studio, install it as an extension, and you can test and see if it worked. So while you have to wait for Visual Studio to load, other than that, pretty easy way of testing that it works, besides writing unit test. Anyways, on to the fix. So let's write a fix. So we have the code fix provider file. I come in here. Again, you got some boilerplate going on, like what is the title of it? So what's going to show up in the light bulb menu? Then you have like what diagnostics is it fixing? So you can fix more than one diagnostic with a fix. We're just doing a one-to-one though. And then again, you're just gonna register something that happens when they trigger the light bulb on that diagnostic. So I'm gonna uncomment this. And I need to put my callback in here, and we're good to go. So we're gonna say like use array.empty. What a creative name. We're gonna give it my document. We're gonna give it the diagnostic and a cancellation token. So again, from here, press Control dot to generate this method. I should have changed my code style rules, but use a block body instead. We're gonna make this async. All right, so what happens in a fix? Again, the thing that we're gonna do is we're gonna grab the current documents. I'm just gonna write this out for you. Grab the current doc syntax tree. Then we're going to find the node that has that original expression in it, so that original array creation. Once we do that, we're going to build our fix. So that means like build a subtree, so build the subtree of our fix, not a tree, a tree. And once we do that, we're going to swap the original expression for our new one, and then return a document with the new syntax tree. So does that like flow make sense? So again, we're gonna find our syntax tree, find that node that we want to replace, then build up a new subtree with the syntax that we want, swap them out, and then return a document with that new tree with the swap in it. And that's, boom, our fix. That's all it is. All right, so let's do it. So here we can come in here, grab our root. So syntax tree, you get by the root. So we have a document. And thank goodness for IntelliCode because it has the thing that I want at the top. So get our syntax root. I have to make it async. One day I'll write a code fix maybe, or get someone else to that adds the await because I always forget it. All right, then we wanna, I had a comment for it. We're gonna find that node of that expression. So like, where is this array creation expression? Like, where is it? So to get it, we'll call it the original expression. So we're gonna get our root, and there's something called find node. So we're just gonna find it, and you give it a span, if you see here. So again, a span is that location in the document, like where is it? And so luckily that's the thing that we squiggled. So we should be able to get it here. So we're gonna, from our diagnostic we reported, there's something called a location, and that has the source span. So that's what we're getting there. So it's going to find what node is associated with that location in my document. So now I have my original expression. We're also going to grab our semantic model because we're going to need it later. So we're going to, it's part of the document. Get semantic model. Again, I forgot to put await in here. And then in order to now build this subtree, the last thing that we need is our syntax generator. So that's that syntax generator API I was talking to you about. We now use that, and it's gonna, I'll show you like super nicely, easily say, make me this, make me that, and it does it. It's pretty great. It's like Beauty and the Beast. So have a syntax generator, getter generator from our document. So I'm now going to do this with edit and continue, fingers crossed, so that we can see the syntax as we're building it up. So this is like my favorite way of doing it. But yeah, so we'll see it real quick. But before I do that, let's stub out what our subtree is going to be. So how do we know what this is going to look like? So we want it to be like, something like empty of int, whatever. This is what we want to change it to. We can use the syntax visualizer inside Visual Studio. And so you just come to your quick launch and type syntax visualizer. I also could have used this to show you earlier that the different ways of newing up a zero-length array have different syntax trees. But we'll just do it here instead. So I can select this expression, and then you'll notice that it highlighted itself in this huge tree associated with my document. And so I can come in here and be like, oh, it's an invocation expression that has a simple member access expression in it, which has, this type in it and a generic, et cetera. And so as you click on these, you can see them also highlighted in the document. So you can see it's highlighting the empty int here, and then when I come here, it's highlighting the array, so I can see what all the different parts of this syntax are. And so this is an easy way of identifying what the heck this tree looks like. We don't have it for the IOperation tree yet, but we're going to build it so rather than seeing just the syntax tree, you'll also be able to see the IOperation tree in here as well. But right now you can't, so sorry. But you don't need it. Y'all are smart, All right, so we have an invocation expression, that simple member access expression. Then we have, that array type that we have to get, and then we have a generic that we have to build. So I'm just going to stub these out in comments so that we can remember what we're building as we do it. So at its root, it's an invocation expression, which is going to be this part. I'm now going to use Control-D, which duplicates a line. New feature. Anyways, so then we have our member access expression, which is this. Control-D, come back. We need our generic, which is just this. Control-D. Now we need our type expression, which was just array. And that is the syntax that we're going to build up. Right? So that's what we're going to build up in this subtree. Let's just kill this. All right. Cool. So now we're going to just start debugging. So we're going to get an F5. Then we're going to hit our light bulb, and then we're going to use edit and continue and the immediate window to see ourselves building up the syntax and see what's happening. All right, cow joke number 2. What do you call a cow with 2 legs? Anyone? Crickets? Lean beef. You're welcome. I'll be here all week. Oh, look, we might have time for one more even. All right, what do you call a cow that jumps over a barbed wire fence? Shredded beef is a good guess, but not quite it. Anyone else? An utter disaster. All right, okay, no more jokes. So from this, I hover over, see, NDC Oslo, use array.empty. If I press Control dot, I've now hit my breakpoint. We are going to have to deal, because it's on the same screen, that the UI element's drawn over. Okay, so hopefully it'll be okay. It's really, let's move my immediate window maybe over here instead. That might have made it worse. Okay, well, we'll just come back to it when we need it. All right, so here we are. Let's build our type expression first. So to do this, from our semantic model, we're going to grab, so we can see here, semantic model. We have a compilation. We want to get a type name by metadata. So we're going to get our type by metadata name. So we're just going to find system.array in that compilation and use that. So that's going to be our array type that we've just grabbed there. And then now we need to wrap it up inside of an expression. So to do that, we're going to do type expression. And then we can use that generator API. And this is all you do. You do dot, and you type in the name that you wanted, find type expression. And now we're just going to wrap this around the array type. All right, so to show that worked, we're just going to come to our immediate window, go to type expression, and just 2-string that all day. Yeah. Boom. our syntax. So toString, if you toString on any of our like nodes or whatever, we just like string output whatever it is. So this is how you can easily verify your syntax that you're building up. All right, so now we've done that, we'll come back up here. Now let's build our generic expression. So the tricky part of this is that we need to know what the generic type is. So what is the type of this array? If we go to our documentation, we'll notice that in our IArray creation operation, we only have dimension sizes and what the initializer is. So that doesn't contain anything related to the type of the array, or the element type in the array. So we're going to just pray that IOperation has something. So if we go to the IOperation interface that it implements, scroll in here. Oh, there's something called type. That sounds promising. If we look at it, what it is, so it's an I-type symbol. If I come in here, not seeing much, but like what implements this? So I can double click to see references, and then sure enough, over here there's something called an IArray type symbol. So if I click on this, oh, I forgot I'm zoomed in. All right, there we go. And look in here. Oh, look at that, beautiful. There's something called element type that gets the type of the element stored in the array. So that's what we need. Perfect. So come back over here. Oh, not to my debugging session. Come back over here. So we need to get what this type is. So first we need to get our operation in order to get any of this, because it was all through the IOperation API. So in order to get that, again, if you remember from that diagram from before, from the semantic model, you can grab your operation. So in here, I can get my operation. So I want it for my original expression. So it's getting the operation for that. From there, I need to get our symbol, or our type symbol. Type symbol, which all this is, I put all this code on my GitHub, so I'll share the link for that later, but you all can access this anytime you want. So from that, we're going to, what am I doing? Okay, getting that. So from my operation, it has a type. So that was that type, but then we wanted to cast it as that IArray type symbol. And then from this, I can get that element type. So what's my element type? So from my type symbol, now I can get that element type. Cool, so now I know what this value is. Now I need to do the other part. So let's just construct this generic expression. So again, I go to my generator. I just type dot, it's probably called generic something, and sure enough, generic name is there. So I give it my identifier, which is empty, and then whatever my element type is. All right, so let's like prove this did what we thought it was gonna do. So again, you can step, gotta love edit and continue, come back over in my immediate window, type in my generic expression, toString that, and now I can see I have empty of type string, or whatever it's going to be. Cool. So now I have that. Cool. Now for the easy part, because we're just wrapping we did all the hard part, which, was finding like array type and the generic, and now we're just like, adding parentheses essentially and stitching them together. So from here, oh, no. I forgot to move this up. Okay, hopefully this works. All right, so from here, write my member access expression. So again, go to my generator. Sure enough, member access expression. Like we tried to make this as easy as possible. So I'm just going to feed it my type expression. So that was where I'm getting that array. And then we're going to dot it with now that generic expression that we wrote. So again, step over it, come in here, say member access expression, toString it. Now you can see it's system.array.empty of the type that we wanted. So we've built up that syntax there. Oops. All right, and now the last and final piece of the subtree. Let's go back. The invocation expression. So it has to be an invocation expression at the root. So invocation expression, take our generator, invocation expression, and then just wrap our member access expression in that. Boom. And so now I should be able to step, come over here. And you get the point where, like, you know, I'm coming over here and verifying. But it's really helpful, especially if it's your first time writing an analyzer, to come through and just two-string everything and make sure that's building up what you thought it was. So now I can see this is exactly what I wanted. It's that array.empty of whatever my type is as an invocation expression. Cool. So now that we did all of that, we have to do these final steps. So remember, swap that original expression with the new one. So now I have this invocation expression. I want to swap that where my original expression was in the tree. So to do that, we're going to create a new tree. We're going to come to the old one, and there's something called replace node. So we make this easy for you, and you give it the old node, which is our original expression. Give it our new one, which is our invocation expression. And then I just need to make a new document with that new syntax tree in it. So I'm going to create a new document, and then going to say document dot with syntax root. I guess IntelliCode is totally trained on all this, so nice and easy. Give it my new root, and then now I need to return my new document. So now, oh, up here I misspelled it. Oh, also, if I decide I want to keep that, we offer to fix your spelling mistakes for you in here. And so we'll offer to switch it, so we'll just keep it misspelled. Why not? Okay. So if I undo my breakpoint, so now I should be able to click continue to go back through my thing that I've been debugging this whole time. So now if I come over here and do control dot, it now will offer to make this an array.empty. So pretty nifty, eh? Yeah, thank you. Yeah, and so you can see that I didn't have to generate that diff view. I didn't have to do anything with a light bulb. I didn't have to say draw a squiggle. I just said where to draw the squiggle. And so like the heavy lifting is already done for you with our templates that we have here. Yes?
Generating array.empty because presumably you've got a system using system directives.
Of course, he's going to call me out on that. Okay, yes. So this only works if you have the framework that has system.array in it. So what I should have done if I wanted to make this more robust was when I initially did my diagnostic, I wouldn't want to report this. Okay. Array.empty is only available, I think, in 4.6 of the framework, I believe. I think so. It was when we added it. So I wouldn't ever want to squiggle it and change it for someone that was not on 4.6 or greater. So what I would need to do is here, if I wanted to make this truly robust, when I report the diagnostic, I would want to, I'm debugging. Let's stop debugging. What I would want to do is wrap this whole thing in a compilation start action. And if I do that, then in here, whatever. I'm great at variable naming, by the way. Then in here, I would want to see so I want to see if that array type exists. So then I would come in, grab my compilation, and just like we did to get that type, compilation, then I would get type by metadata name and see if system.array existed. And so here I would see if this exists, and then if I forget what is this. So if it's not null or whatever I'm supposed to do for my check there, then I would put this in. So then this now does the check to see, do you have system.array available in your compilation, and then we'll only offer to give the diagnostic and the fix if it exists.
That's cool, but that's more complicated than I was going to ask.
Oh, okay. What was your question then?
You don't have using system at the top. What does it do? So instead of saying array.empty, which isn't going to work if you don't have using system in the
I see. Okay, well, let's find out, shall we? So the question is, if they don't have the using for this fix, what happens? I believe we add it for you, but there's only one way to truly know, and that would be to test it. Oh, a cow joke. I don't have any more, but I have fungus jokes. Do you all know what a fungus is? Oh, does someone have a joke for me? Okay, so the joke is, how do you count cows? Is this appropriate, by the way? Whoever said it? Oh, with a calculator. That's pretty good. I'm gonna take that. But how does a cow count how many legs it has? Because apparently they're flying off the shelves. All right, so okay. Dun, 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 dun. Oh, maybe I'm not targeting even the right thing here. Okay, let's see. Control dot. Let's see what happens. Oh, it doesn't do anything. Oh, because it's qualified it. Yeah. Oh, nice. Look what we do. We're so like even less work for you guys. You didn't even have to check that it was there. So, yep, there you go. And so now I correctly checked that, as I should have done in the beginning, but I didn't want to make it more complicated. That this exists in their compilation, and then offers it, and then, yeah, if you don't have the using, we'll qualify it for you and put it in there. Cool. All right, what time am I over? 40. Okay, I have 8 minutes. So I just bragged to you all that iOperation was so abstract or high level that it works over multiple languages. So let's test it. You say what languages it applies to up here. So we're going to do language names, Visual Basic, and then we'll do it for the fix as well. I believe I just stayed here. Language names, Visual Basic. All right, so now let's go and test it again and open up a VB project where we do same thing and see if it works. All right. Why did the mushroom go to the party? Anyone? We're on to funguses now. Because he was a fungi. I know, guys. Thanks for the laughs. All right. The other one that you have to tell, so you can't tell like that joke without telling the opposite direction one. Why did the fungus leave the party? Because there wasn't mushroom. Terrible. But hey, maybe you'll make a friend tonight. Who knows? Tell some jokes. All right, so here we are. We've loaded, thank goodness, because I'm out of jokes. Open a VB file. Hopefully, once my analysis runs, yep, now you can see that same thing here. It's got our same message, and I should be able to do control dot. And yep, it offers to use it and uses the VB syntax for me. So because it uses syntax generator API, it's language agnostically creating my syntax. So it used the VB syntax in here for me. And it works with VB as well. So cool. That's how we wrote it. And again, like if we look at how much code that was besides my like comment craziness that I put in here, the fix was probably like 20 lines, maybe 15 lines of code here. So not a lot. And then remember, our analyzer was barely any at all, just this. So once you like wrap your head around like what they do, which once you write the first analyzer and get to work, writing anything thereafter is usually much easier. So yeah, there you go. So back to slides. Yeah, all right, so here you go. Here's an analyzer I wrote for you guys. Analyzers are not scary. So yeah, there you go. That's the takeaway. If you want to see what some community-based analyzers that exist there today, so some people have like gone ham. So we're writing a bunch of the FX cop analyzers or FX cop rules as Roslyn analyzers, so you get live feedback on whether or not you're like using the best practices from FX cop or like the security things. So we've written a lot of those as analyzers. A lot of those use iOperation. So if you want to see that in the works, you can look at our repo for that. Roslinator is something that like a guy wrote 180 refactorings and code fixes or something like that. So if you need examples or he might have written one that you want, like check it out. Someone on my team wrote a bunch of style cop analyzers as part of his open source project that he has for this. So he wrote all the style cop rules as Roslyn analyzers. So you can use that. SonarCube wrote a bunch for SonarLint. I think they also have hundreds. And then there's CodeCracker, which is another kind of grassroots one that popped up that does a lot of VB ones as well, I believe. So if you want to like see examples in the wild or use them yourselves, you can contribute to these projects, write your own. A lot of people have written their own for their teams at their company or whatever. Yeah. And then here is a ton of references for you. So like if you want to learn more about the APIs, we have a nice overview that I didn't write, which is why it's really good. Then if you want that source code index, so what I've been calling the documentation, that's source.roslyn.io, we have various guides to help you get started. If you really want to find analyzers that exist today, we don't have a registry or anything, so you just sort of have to like Google Roslyn analyzers or go to NuGet.org and type analyzer, or go to the extension gallery and click analyzer and do that. Someone made this website called Awesome Roslyn, which sounds pretty cool, right? Skip verification. Let's just, oh, you can't see it. Escape. Oh no, how do I get out of presentation mode? Okay, here we go. And so it's like a list of books on Roslyn, tutorials on Roslyn, and different open source projects that use Roslyn. So that's something that you want. You can do that. And oh man, he put so he did my job for me and put all of this in here for you. So that's Awesome Roslyn is the GitHub project for that that you can use, etc. And yeah, I think that's it. How much time do I have? I have 3 minutes. So does anyone have any questions? Oh, yeah.
What are performance of ID and population?
So the question is, what is the performance of these? We're actually building a tool right now to be able to measure the performance of these. We don't actually have a way of doing it right now. There's certain actions that you shouldn't, well, not that you shouldn't register to, but that require, so if you write anything that requires the entire compilation, so you have a compilation end action that requires the whole compilation to be done in order to access that. So that one will have like, will take longer than the other ones. But if you write these, unless you like are writing infinite loops in them or mining Bitcoin in them, they should be performant. Yeah. Yeah.
Can you build your sort of replacement syntax tree from string? So instead of all those little steps that you did, could you have a string and say, I want to put array.empty, square brackets, get the type?
I see. So the question is, can I just like have this, so in my example, could I have just done system.array.empty of the type and just have it generate the syntax tree for me? Someone wrote a tool that does that, I believe.
Because when you read the code in the first place, when the compiler does it, that's what it's doing, right? So isn't it the same?
Sort of. But yeah, well, so it has to, for the array, I needed to make sure that it was current. I can't just have like a string identifier array. It needed to be the array linked to system.array. And I need to know like my generic type. And so how would you get that from a string input?
The generic type you'd have to add in.
Right. I believe though someone, I can't remember the name of the tool, but it's like, just do like Roslyn string to, what is it called? Oh yeah, Roslyn Quoter. That's what it is, Roslyn Quoter. And if you go there, you just type in like what syntax you wanted, and it shows you what you have to build out with the generator or the syntax factory to get it. Yeah, so people have written like all sorts of cool tools for writing these in Roslyn as well. So go wild. Any other questions? Cool. Well, as I said, if you're not here for my comedy, I'll be here all week. So just find me at any time and happy to talk about whatever. So also, if you want to write these, the Roslyn team, our team has a Gitter channel, gitter.im/Roslyn or something like that. So if you're having trouble with any analyzer that you're writing, just hop onto Gitter and like our entire team is there. So you can just ask us any question you have and we're happy to help. So yeah. Thanks guys for coming out. Enjoy the rest of NDC. Thanks for coming.